Welcome to qnawire.
Okay, so we were being asked to find the intervals on which f is increasing or decreasing, and then we were being asked to find the local max and min and intervals of concavity and inflection point for f of x. So before we proceed with this problem, we have to take note of a couple of things. Take note of something. Since it is f of x equals x squared times ln of x, I think it is very important to consider the domain of this function. Just in general, whenever you're doing these kind of problems, it is really a good idea to just get a mental idea of what the domain is. And since we're looking at ln of x, we know that the domain for ln of x is all x greater than 0. So this is the domain. Because any number, because the ln function cannot equal 0, and it doesn't accommodate negative value because the graph looks something like this, kinda. And so that means when we're evaluating our point and looking at our interval of where the function is increasing or decreasing, we can only look at values greater than 0. So speaking of finding values where increasing and decreasing, we apply the first derivative test. So in this case, we will apply the product rule. This will give us 2x ln x plus derivative of ln of x is 1 over x, and then since it's x squared over x, that gives us just x. And then we can factor out a x, so this will give us 2 ln x plus 1. And then we set this whole thing equal to 0. So we get x is equal to 0, and then we have to find out where 2 ln x plus 1 is equal to 0. So 2 ln x plus 1 is equal to 0. We get ln x equals negative 1/2. And then x is, we apply the exponential function. So we just apply e and e. And then we get x is equal to e to the negative 1/2, or simply 1 over the square root of e. So now we are going to apply a sign chart. And since we are looking at the values of 0 and 1 over the square root of e, we ignore any values less than 0 because our domain is only x greater than 0. And when you plug in values between 0 and square root of 1 over the square root of e, you get a negative sign, and if you apply anything very positive, you get positive. So now that we know the signs of f prime, we know where it is increasing or decreasing. So it is increasing from 1 over square root of e to infinity, and it is decreasing between 0 and 1 over the square root of e. And we know that it has a local min because it's going from, it is decreasing and then increasing. So we have a local min occurring at 1 over the square root of e. So x is equal to, and there's no local max. And now we're going to find the concavity inflection point, which requires taking the second derivative. So you'll apply the chain rule, you'll apply the product rule again, but I've already taken the derivative before, and it would simplify down to 2 ln x plus 3. We set this equal to 0, so then we get ln x is equal to negative 3/2, and then we apply our exponential and exponential on both sides, and this gives us x is equal to e to the negative 3/2. So now we will create a sign chart to evaluate where our function is where our concavity is positive or negative. So we're looking at from 0 and e to the negative 3/2. looking at signs for f double prime in this case. And so if you we ignore these, any number less than 0 because their domain is greater than 0. So numbers, if you plug in value between 0 and e to the negative 3/2, you get negative. And if you apply numbers greater than e to the negative 3/2, you get positive numbers. Since it's negative, that is concave down, and this is concave up. So in interval notation, so concave up, which is our U sign, is from e to the negative 3/2 to positive infinity, and then concave down occurs, which is a upside down U, occurs between 0 and e to the negative 3/2. And our inflection point, inflection point occurs when our sign for concavity changes, which occurs at e equals negative 3/2 because it goes from negative to positive. It goes from e to the minus 3/2. It is, sorry, x equals e to the minus 3/2. And there's no other inflection point because there's no other place where the sign changes. And that is the answer to our question.